Okay, hi everyone. I'm gonna start by looking at the Piazza thread if there are any questions there. I see there are a few, so let me see what they are. So I'm not sure what the first question is. In Piazza, maybe if the person that wrote it can clarify. Otherwise, maybe I'll move to the second question. Okay, so there's a question here about removing missing values. This is question number 227 on Piazza. And the question is, removing missing values using na.omit function will remove 36,000 rows. That's like 90% of the data set. Guy says not to remove too many rows, but then asks to use na.omit. What's the best approach to handle missing values for this data? So what I said was don't remove more than you need to, but it's okay to omit missing values in this project. So if you have 90% missing values, just drop 90% and work with the remaining 10%. The only alternative is to use imputation or other techniques, but I said we don't need to do that for the project, so just drop them. But what I meant when I said don't drop more than you have to, the point was to drop only the rows that you need for the specific question or task that you are working on, and then in the next task, you may want to drop other rows. So if you answer a question about revenue, use only rows that have revenue figures, but then if in the next question you want to work with some other variable, then only remove the rows where that variable is missing. And then there was another question on the Piazza thread about midterm. So there is no midterm. I'm going to go to the last question on the Piazza thread, but in the meantime, feel free to write questions in the chat. Okay. So what is the last question on Piazza? Is it permitted to borrow or steal or use with proper credit other people's code? For example, I need one hot encoding. Could I Google and use a snippet of code I might find in Stack Overflow or similar? So thank you for asking this question. I'd say the answer is no. But you can Google the algorithm and see maybe if you find it in a different language, then you can use the same algorithm, or you can be inspired by that. Or you can look at some R code and re-implement it yourself, but don't copy it. You can read some code and be inspired and then write it yourself. And it's better if you don't Google exactly how to do something very specific and then do it very closely to what you see, because that could be construed copying. Like I said, the code that you write should be your own, not other people's code, whether they're fellow students or you find that on the internet. And yeah, if there are any more questions or clarifications about issues of using code on the internet or Googling things, just let me know. I'm happy to answer. My goal is two. I have two goals. The first one is to make sure that you learn, and I think as in many courses, or maybe all courses, you learn by doing. So if you see code, and even if you think you understand it, but you just take it and you copy it, you will not learn as much as if you struggle with writing it yourself. The second goal is that of evaluation. I want to make sure that I evaluate students properly, and again, that would be an issue if you use other people's code, and when you say it's like something very specific or small, it's hard to draw a line. What is small? 5 rows of code is okay to copy maybe, but 50 no. So I just say no code copying. Just write your own code. You can be inspired by algorithm or code in other languages and kind of take that as a inspiration or an idea, but sit down and write it yourself without kind of looking it side by side and translating it, or just copying and changing the variable names. Okay, let's see if there are, in the meantime, so there are no questions, which makes me worried that maybe you don't hear me, or maybe just everything is clear. Let's see, can you hear me? Okay. Okay, so while whoever is watching get a chance to um, type some questions, maybe I can just say a few words about the course right now. And so I hope you're all working on the third module, and you're doing well there. I think it's important for the project, so make sure you understand the nuances there before you finalize the submission of your project. And the other thing I said earlier, which I just want to take another opportunity to remind you, is the next module will have some math involved, specifically probability, algebra, and calculus. So take the time and prepare. I got one or two private questions on Piazza, which resources I would recommend to if you need to remind yourself these topics. And it's kind of hard because there's so many books or lecture notes online. Yeah, so I would say for linear algebra, what's important is dealing with vectors and matrices and things like inner product and matrix multiplication of matrix by a vector, a matrix by a matrix, and also things like matrix inversion and this kind of things. Not super advanced. We don't need so much. For example, spectral decomposition. So I would say mostly focus on the basic stuff in linear algebra. In calculus, what we need is the concepts of differentiation, and including partial differentiation. So when you have a function of multiple variables and you want to differentiate it with respect to one of the variables, holding the other variables constant. And so we'll make use of that. So refresh your knowledge of differentiation and partial differentiation. And both, so regarding books, there's just so many options. One popular linear algebra textbook is by Gilbert Strang, and I think it's actually very expensive, but I'm sure you can find it in many libraries, and I think there are also some PDF versions on the web, or you can find some lecture notes some other place or a textbook you had. Or also in my book on probability, one of the appendices contain linear algebra, so you can just take a look there. It's available on theanalysisofdata.com. And you just click on the viewer and go to appendix. I forgot which appendix it is, C or D or something like that. For calculus, again, I think this is so standard material that any reasonable calculus textbook will have. Again, this is something I cover in my in one of the appendices to my probability book, but I don't want to say that that's the best source. That's very condensed and very hard to understand. It's not meant as a good source to teach someone that. It's more meant as a reference and to remind people. So if you think you just need a quick reminder, that's not a bad option, but it's not necessarily the best place to go and learn that from scratch or from a very low level of knowledge. The last topic is probability, and there we'll need the concepts of probability and conditional probability, probability mass function, probability density function, expectation variance, and the Gaussian distribution, including the multivariate Gaussian. And that is usually included in a first course on probability. You can again use there's a long list of textbooks. I think there's a popular book on probability by Sheldon Ross. You can also use my book, like I said, available in theanalysisofdata.com. But again, not saying that that's the best introductory material. This is not the easiest to follow if you lack the right background for that specific book. So pick whichever source is most convenient for you. I'm not going to ask in the book I'm not going to ask in the course to do super heavy math, but you will need to follow along with whatever derivation we're doing or understand the basic concepts. It's just really essential to have an in-depth understanding of data analysis. Okay, so we have some questions. Let's see. On the YouTube channel. Okay, so can you comment more on Q3 for the project? What types of visualization are you expecting? Histograms? Do you only care about charts for the top 10 movies? So let me make sure I have a copy of the project in front of me. Okay, so there are really two different requests here. The first, to graph and describe the relative proportion of titles having the top 10 genres. And so this is pretty clear what I request here. So basically out of all the titles, what's the percent of let's say action, comedy, and drama, or whatever are the top 10 genres? So is it like 10% or 15% or 30% and so on? And so yeah, you can do it using, for example, a bar graph. The second issue is examine how the distribution of gross revenue changes across genres. So this is a little bit more tricky. You can just do, for example, a box plot, which gives you a concept of the gross revenue distribution. But then I'm asking, how does it change across genres? So I would suggest not to just do one box plot for every genre, because then you kind of lose the ability to compare across different genres, and so you need to think about somehow um, doing perhaps multiple box plots in the same graph, or multiple histograms in the same graph, or some other kind of way to arrange in one graph the dependency between the distribution of revenue and the top 10 genres. I don't want to, give a very precise recipe, because this is part of the question to see what you come up with. Okay, next question. I have years of experience in the industry using SQL. What do you think about using an R library, for example, SQLDF, which lets you use SQL queries to work with data frames? So I'm not sure exactly, are you asking specifically for the homework or in general? I think it's probably good to learn how to do things, with other tools, not just with SQL. Although SQL is extremely useful, extremely powerful, but and I have to admit, I don't know SQLDF. How does it work? Does it just take a SQL query and translate it to work on a data frame, perhaps? I would suggest that you try and learn how to do it without SQL. I think it will enrich your knowledge. Going beyond the issue of grading and homework, I think it's worth the time investment to figure out how to do it. I'm not asking anything really hard. In fact, probably it would be easier to write a simple R program than a complicated SQL query to accomplish something in this course. So what this gives me, it gives me a hint that you really need to kind of have a better understanding of R, because the programs that, like, for example, compute the average, or compute the average for the proportion of genre of movies in different genres divided by the overall number of movies, or so on. These are fairly simple, so I'm guessing that if you feel like SQL is easier, you probably could really benefit from learning a little bit more R. So I would actually suggest you try to get out a little bit of your comfort zone. If you really need to do that in some case, I suggest you don't do that most of the time or everywhere. I think you're going to probably learn more by trying to not use it. Okay, next question. Using implementations as references. I've seen the heuristics of don't have any code open while you work on your own. Is that a good enough heuristic? Oh, and there's a continuation. Or in other words, if I find an implementation and read the whole thing and then close it and code it up as closely as I can manage, is that fair? I guess depends on your memory. If you have a really good memory, that is not okay, because that would be the same as just keeping it side by side. I mean, if you have photographic memory, a very good memory, and the end result is very close to what you see, it doesn't help me that you didn't have another window open in the browser with the code. It's not going to help me. Like I said, my goal is that you learn, number one, and number two, to evaluate. And if you have a really good memory, that's not going to help for either of these if you do what you suggest. So instead, what I would argue is it's okay to, like, if you say stumble across a piece of code, Um, it's okay to, if you don't know how to do, it's okay to take a look, but then don't just rush right away to write it down and write it down very similarly to what you saw. Just try to read it, understand it, let it sink, and then try to recreate it from your own understanding. So like try to learn from it, kind of compress it into the algorithm, or what are the very basic things that are being done. Like, I need to do 1 and 2 and 3. Okay, I learned that, and then I kind of let it sit down. I figured out what I need to do, and then I recreate the tasks 1 and 2 and 3 after I gain the knowledge from wherever it is that I looked it up. And so if this is kind of vague, I would say try to avoid, if you think that's a challenge for you, try to avoid looking up code on the internet. The homework and the projects are designed in a way that you don't need to look up code on the internet. It's not something I expect you to do. It's not something that you should have problems or trouble if you try to avoid. The homework is designed so that you can do it completely on your own. So if you think you're not sure, or you have good memory, or just avoid it. Just don't look up code on the internet, especially not code in R. And that's one way to handle that, I guess. Okay. Yeah, so saying, stay away from looking at implementations in R. I would say, definitely it's okay to look at R code, but not like an R code that solves exactly what you need to do in the homework or in the project. So, if you need to do a specific task and then you search for it and you find exactly how to do it with R, and then if your implementation is fairly close, then it kind of tells me that you haven't really internalized it and recreated it yourself. Rather, you mostly copied it, which would be a problem. So I think it's okay to look at other R code. Just try not to look at how exactly a task from the homework on the project was accomplished. Okay, should one stick to Plier? You don't have to. This is just one useful package. You can avoid it. You can use other tools. I think there is benefit in learning how to write elegant and concise code, and code that is maintainable, and code that you can change a little bit and get an answer to a different question that is similar. So I think it's probably going to be helpful for you to try and figure out how to work with these constructs, and how to write elegant code, and how to be able to write relatively short code that you can change later to get a different effect. So I recommend trying to use it, learning it, but you're not required. You can write your own code without Plier package, or you can use other packages as well. That's fine. It's not Plier is not the only package. You shouldn't feel like you have to use it. Can I take advantage of my previous knowledge of SQL and use that in R? And so I try to answer that. I think the code that we need to write in this project, or in the homework, that you may be able to write a SQL query instead, is actually quite simple and straightforward. And if you think SQL would be easier, kind of makes me feel like it would really benefit you to learn R a little bit better. So I really suggest not trying to do everything through SQL if that's a tool you're very familiar with. Nothing against SQL. SQL is super popular and people use it all the time. And it's useful not just for R, it's useful for data, a querying database and many places, but I think it probably makes sense to learn also how to write some simple R code to do similar strategies. There's another comment here about the book, so I should take a look at this book. I didn't look. Maybe I don't know if you put a link to the book. Maybe you can put a link to the book. I'm curious, or send me. Maybe better, just send me a private post on Piazza with the link to the book. I'm really curious to take a look. What is that book? But like I said, in general, you're more than welcome to read other books and other visualization sources and so on. I don't want to limit you. Just don't look up how to do exactly what I'm asking you in the homework. And so please, I do suggest go and read the book, enjoy, learn, and maybe share your knowledge with others. If you see in the book a solution to exactly what I'm asking to do, then maybe just skip that part or read it, but then try to learn it rather than immediately go and write it down as your own solution. So I actually encourage people to look at other books and so on. I don't think that's a problem. Okay. Do quantitative exact methods exist to identify the same trends or relationships we might identify when doing plotting and visualization? Yeah, that's a very good question, and I think a very deep one. There is a lot of analytical techniques that can accomplish some of the things you can do with visualization, and vice versa. There's visualizations that are substitutes for analytical methods. I think both have pros and cons. So let's maybe just start with an example. Okay, so maybe one example could be, is the data coming from a Gaussian distribution? Okay, so if we want to do it with the visualization method, we may do a QQ plot, for example, and look at how the quantiles of the data differs from the theoretical quantiles of the Gaussian distribution. I think this is should be in either the second module or the third module. So that would be a visualization approach to answer this question: is my data coming from a Gaussian distribution? And then there are also tests, whether they're parametric or non-parametric, that are analytical and give you a score. Your score of the test spits out for whether the data comes from a Gaussian distribution is so and so, and you have a way to interpret what this score means. And so I think there are pros and cons. So the analytic methods, they have pros that they're not interactive, so you can repeat them many times quickly without having a human look at the graph every time. You can do it at night, you can do it every hour, every minute. You don't need to hire people to look at it. And also they come with some perhaps statistical interpretation or probabilistic interpretation or so on that you can kind of feel somewhat comfortable about, like statistical testing. Maybe you get p-values or confidence intervals that can kind of help you make decisions. So these are advantages of the analytical tools. Visualization tools have other advantages, and their advantages are more, in my opinion, in the direction of in working with data interactively. So it's not that you just want to answer that one question: is the data coming from a Gaussian distribution? That's the only question you want to answer. If you just want a yes or no, maybe a test would make more sense. But if this is part of a bigger task of investigating the shape of the distribution, and so this is, you have an interactive process. So you say, okay, let's do a QQ plot, and you do a QQ plot, and you find out that the tails are heavier, and maybe the tails on the right side are different from the tails on the left side. And so that already gave you information that you didn't ask, and you didn't code it into the analytical method to give you an answer, but you discover by looking at the graph, the QQ plot. Then you can say, okay, let me now draw a QQ plot of against the t distribution. Or maybe let's transform the data with the log or some other distribution, and we'll do a QQ plot for the transformed data. And you can keep kind of trying new things, and that's something that an analytic method is not going to be strong at. It just you have to be very careful at how you phrase your question. You have to find the analytic method, and then you get the answer, and then you take the answer and you do what you want with it. But it's not so much interactive. So I would say both have strengths and weaknesses. It's useful to know both methods, both visualization methods and analytic methods. Okay, next question. We can calculate the variance for regression. We can do k-means to identify clustering. Is visualization then just a previous step before running or executing more precise methods? I think in many cases it is a step before you do an analytic method, but there may be other cases where that's the end of the road. That's the end of it. So, like if you want to do some sort of exploration of the data, and you want to find out, like for example, like I don't know, let's say how did our, like we have a business like Netflix or whatever, and you think there was a bug that happened at a specific point in time or during 2 weeks, and you want to see how it affected people, the users. So you approach this with visualization and draw many graphs for different countries, for different types of users, new users and old users and international users, and what happened to the number of, if it's Netflix, the number of movies that were streamed, or the length of the length that was streamed, the average length overall. Were there times that had some outage where looks like the number of streams just dropped very seriously? So you can just do a lot of visualization and come up with conclusions based on visualization. That's perfectly sufficient. There's nothing wrong with it. It's more interpretable. If you want to share it with people in the company, you can share the graphs with them, and they may understand it better than some sort of statistical test, for example. So I'd say it's not always a prerequisite, and it's not necessarily a weaker or a secondary tool. It has different pros and cons, and I think it's extremely useful, even by itself. Okay. For question 8 on the project, I'm struggling to understand what qualifies as an insight. I'm also struggling to formulate the question in a way that doesn't give specific examples. And then, is it fair to say in general that an insight is a significant correlation or trend between any two variables not listed in the question above? So I think that's certainly one example. Another example could be a lack of correlation. But I think just a correlation, like it'd be nice if you can tell a story behind it. So if you just look, let's see, you look at two quantities and looks like there's some correlation, and they say, okay, X is correlated with Y. Is that an insight? I would say, think about the context. The context is studying movies and what makes them successful or not successful, and different genres and years and so on. And so I would say an insight is something that you can kind of compress into a sentence or two, and you take that sentence or two and it's backed by graphs. You take that sentence or two and you explain it to someone that has some understanding about that area of movies, and they will be able to connect this to what they know and kind of make a story out of it. And maybe it's surprising. If it's surprising, then it's like, oh, I didn't see that happening. And then it's helpful if you can still explain why it's contradicting your intuition, or why it's surprising. So if it's a surprising insight, I would say, first describe, I would say, what you would expect, then show what the data tells you, and then say, okay, here is why why this makes sense. In the beginning, I was surprised by that. I wasn't thinking that I would get that, but now thinking about it again and looking at a few more graphs, I actually think it does make sense, and here is why it makes sense. For the non-surprising insights, it's a little bit easier. You basically tell you the story of what you saw, and it needs to be something that people understand and can relate to, not something completely random that everyone is scratching their head and there's really no explanation for. Okay. So question about grading and rubrics. So the guidelines is basically, I mean, I think it's these are not closed-ended questions. They are somewhat open-ended. So I'm going to try and me or the grader, the TAs would ask, first, did the student understand the question? Did the student did what was asked? And then, there's all sorts of nuances, like the question may be somewhat complex, or there may be some hidden things in the questions, and did the student notice them, or did the student just ignored some important issues or concepts without paying attention to them? And so I'm not expecting a dissertation or many pages on every single question, but basically some reasonable amount of diligence and retrospective, given the tools that I'm going over in this class. So I'm not asking to use tools we haven't covered, but using tools we've covered and concepts we've seen, and just your basic imagination as a data scientist. I'd like to see more than just the bare minimum without kind of digging deeper and so on. And that's, for example, why I gave the question with the insights. So this is probably the most open-ended question. Following the visualization analytic method discussion, it would be enough to say clearly this graph proves that for an academic paper or an exec report. I'd say let's start with the exec report. It's easier. So for an exec report, actually, graphs are probably easier to digest and to use than analytic results. Although in some cases they should be augmented with figures. Like let's say you see, one quantity be bigger than other. You want to also say in numbers by what's the percent or so on. Like, let's say we talked about maybe there's a bug, and we found out that it affects streaming. And we also want to say, here's the impact on members in terms of numbers, not just in terms of the graph of usage. Also, here's how many less movies were viewed, or here's some other kind of measure that you want to add to the graph. But yeah, the graph by itself is certainly sufficient without an analytic results in many cases. Maybe not every single investigation, but for many cases it is. For an academic paper, I think it really depends on which academic community you're talking about. There's so many different communities. There's the more mathematically rigorous and analytical communities, and there they would not be happy if you just show the graph. There they would like analytic results or even a mathematical proof that proves your point. And then there are other communities. There are community on, for example, data visualization or visual analytics. And there are communities on social sciences, computational social sciences. There's a community on systems, and so on. So many of the communities, yeah, a graph would be sufficient. You don't need an analytic methods to support your conclusion. So it depends a little bit who's reading and what they're used to. Every reader would have their own background and what they feel comfortable with. I think in general, it's good that people are familiar with both and they can kind of navigate and write and understand both of these approaches. Okay, we're almost done. Let's see if we can squeeze another question or two. What visualization or modeling method do you recommend for extracting trends or information from noisy data sets? I think one important question here is the noise in the data, is it something that's inherent in the data and you care about it, or is it maybe corrupted value or a data entry problem? If it's the latter, then I think it makes sense to detect the corrupted values and remove them. And I think it makes sense to use visualization or modeling approaches for that. There are areas of outlier detection, and you also need to use some sort of domain knowledge to understand what are the chances that that's corrupted value and so on, or maybe try to triangulate that based on multiple observations around that value, making sure that, yeah, that's really corrupted, and remove it. If this is rather something that's in the data and you don't want necessarily to remove it, I think it may make sense to kind of separate the problem into how would you model or visualize the data without this noise, and then separate question is how would you do it with the noise, or how would you characterize the noise? And so that will kind of let you get a very clean, whether it's a graph or a model or analytic technique or whatever it is, a very clean answer for the data without the noise. You remove the noise. There are different techniques for doing that. But then also make sure that you explain, we also had the noise, and here's what it looks like, here's the distribution, here's the intensity, and we should be aware that the noise also exists in the data, and it has some characteristics that whenever it's stationary or non-stationary and so on. So it's kind of a difficult question. There's a lot of kind of smaller issues in it, how to detect outliers, how to diagnose noise, how to figure out if the distribution, let's say, changes over time or is stationary. I think it may depend on the domain you're in. For example, if you're talking about numeric data, the techniques may be different than if you're talking about categorical data. So it's not an easy question to answer. It kind of depends what the data is, and yeah, I mean, probably depends. I could see several different answers to which techniques you'll use depending on the details here. I think that's about it for now. Thank you everyone for logging in and listening and for your questions. And yeah, I'm continuing to monitor Piazza. I may be a couple of days, sometimes late. I also put the contact information for the TAs on one of the posts that are pinned. And so if you want to contact any of the TAs, you can do that. One more comment, and I also mentioned that in a post. The TA that's grading your assignments is going to stay the same TA for the remainder of the course. So whoever graded assignment 1 will grade assignment 2 and 3 and the projects and so on. And if you still don't know who that TA is, you'll see that when you get the grades for homework 2. The TA should write down in the assignment, when you look up your assignment in T-Square, you should see the name of the TA and the email. And if you want to ask questions in addition to my perspective, you also want to ask the TAs, whether you want a different perspective or you don't like my perspective or whatever is the reason. Feel free to email the TA that is assigned to you. That's the TA that graded assignment 1 or that is going to grade homework 2. You can see who it is on T-Square in a few days when the grades are released. And you can also contact other TAs. But I think it makes sense to distribute a little bit the workload among the TAs. So probably it makes sense to first try your TA, but it's not against the rules if you want to try other TAs. Maybe you want more opinions. That's perfectly fine. Okay, thank you very much, and bye-bye.